So this is my ECS 1011 bonus project. So I'm making uh, an animal deterring alarm system. In this, we input sound value sensors. We get a sound sensor value, and if that is greater than the sound threshold, it will sound an alarm and switch on the LED. So this is used to mimic an animal fighting, and then the buzzer and LED make the animal run away. And we want this to happen only during night, as during day there can be human noises. So this only occurs when the light sensor value is low. But in some areas, the it can be daytime for long periods of time. So we control the limiting value of what is like if the potentiometer value is greater than the light value, the event will not go off. But if not, the event will happen, and the button is used to terminate the program. And this is the LED, so it's displaying what the project is. I initially wanted to display the sensor values, but the LED updates too slow for that. So and then yeah, so an alarm went off, and these are the two graphs. Over here is the sound sensor versus time graph, and this is the light sensor values graph, and this blue dot is the alarm. So an alarm went off, so that is the event. It shows that an animal attack occurred at that time. Blue means the animal attack occurred at night, and then I'm displaying the sensor values over here. So the sensor values are converted to ones and zeros. 1 means the light sensor is high, and 0 means it's low, and this line is what's considered the day or night threshold. So above this line is day, and this is night, and this is the sound sensor values. So now I will apply a light on this. So the current threshold is 0.43. So now I will sound an alarm. I will make a sound. So the most effective way is coughing. So this is a little embarrassing, but see, even though the sound sensor values went above the threshold, which is 0.6, there was no alarm. That's because the potentiometer value is 0.4 and the light value is 0.73. So the alarm did not go off. Now I will reduce the potentiometer value. Like I will reduce it. So now increase it. So now the potentiometer is 1, and even when the light is there, the alarm will go off. See, the alarm went off, and now I will reduce the potentiometer. So yeah, see, now it's the red dot for attack during day, and now I will reduce the potentiometer to 0, and now so now no attack goes off because it's 0, so all the light values are greater. So that is all for my project, and yeah, I will yeah, so the sensor went off again, so the buzzer is going off and the light yeah, so the light is also going off. So now I will end it by pressing the button, and pressing the button, the system terminated. That is all. For CL01, the device operates by continuously monitoring light and sound levels using sensors connected to an Arduino Nano. The sound sensor detects sound above a certain threshold and the light level within a specified range. And this algorithm activates a buzzer and LED for 3 seconds, and this creates a responsive system that deters animals. For CL02, this program utilizes a while loop to maintain continuous operation, constantly reading sensor values and updating outputs. The conditional statements are used to decide when to trigger the alarm based on sensor readings and control logic, and it also integrates loops and conditionals. For CL03, the project includes custom functions like the initialize OLED and display right to handle initialization and updating of the OLED display. These functions encapsulate certain tasks, promoting code modularity and reusability. For CL04, the program simulates engineering application by converting analog voltage readings to meaningful light and sound intensity levels, creating a mathematical model of environmental conditions by creating the scale value as the voltage reading divided by 5. For CL05, the program plots real-time data from both the light and sound sensors using MATLAB's animated line and plotting functions. For CL07, I connected the light sensor, sound sensor, potentiometer, buzzer, LED, and OLED to the Arduino, which interfaces with MATLAB on the computer. By writing code that reads from the sensors and control actuators, I've effectively integrated all hardware components, and a block diagram like this would explain it clearly. So human-animal conflicts are on the increasing trend due to increasing population, deforestation, drought, etc. And this has caused the human-animal conflicts to reach alarming levels. Many human lives are lost in conflicts around the globe. And this module helps prevent that by scaring animals away when there are animal attacks.